So in this video, we're going to go over an arithmetic series, and we're going to derive the formula for finding it. So the difference between a sequence and a series is a sequence is just the set of numbers. So it could be like T1, T2, T3, and on to Tn. But a series is going to be T1 plus T2 plus T3 plus and on. So we know from what we had learned before that T1 is just T1, and T2 is actually T1 plus a difference, and T3 is T1 plus two differences. And if you need to review this, go watch the video on sequences, arithmetic sequences. So if I wanted to find the sum, so we say the sum of some series is Sn, and that's just T1. But instead of writing T2, I'm actually going to write T1 plus the difference. So that's T2, right? And then if I had T3, that's going to be T1 plus 2D. And we keep going. And eventually we get to near the end, which is going to be T1 plus n minus 1 times the difference. So that's my nth term. So this is kind of handy. Now, what if I wrote this in the same way and I say, well, let's say Sn, but I'm going to write it backwards. So now what I have is T1 plus n minus 1 times the difference. And that's my first term for this one. And then I have T1 plus n minus 2 times the difference. And then I keep going until I get to the very beginning of the sequence, which is just T1. Now I'm going to add these. So if I add these, what I do is I have Sn plus Sn, which is 2 Sn's, right? But I'm going to add them so that this term adds to this term. And I have this term adds to this term. And then I would have the missing term here, and then these terms. They all add up. So what I find is that this term, it's 2 T1s. So I have 2 T1s. And then I have this, which is n minus 1 times d. But there's no n1 minus 1d. There's no jumps. So, but I have jumps here. So I have this n minus 1d. And that's my first term. And then if I added my next term, what I'm going to have here is I have 2 T1s. So I have 2 T1s again. And I have a d and n minus 2d's, which is the same as n minus 1 times d, because I have n minus 2 plus another one. If we keep doing this, what we find is eventually we get all of our terms to equal this. But how many terms are there? Well, this is Tn. So there's actually n terms. So I'd say, well, that's 2Sn equals n times 2T1 plus n minus 1 times d. But I just want to solve for Sn. So that's Sn equals n over 2 times 2T1 plus n minus 1 times d. So we've kind of gone through, this may look a little muddled, but I'm just grouping these terms, like this term and this term. So when I add them together, this term is missing on this line. It's a void there. And then this term, the final term. So T1 and T1, I get 2 T1s. There's no D's here, but there's n minus 1 D, so I have n minus 1 D's. So it's always going to be 2 T1 plus n minus 1 D for every term. But there's n terms. So I have n of these, and then I divide the 2 out. So now I have the equation for the sum of a series. Now, what we'll do, we can also write this in a different way. We can have Sn is equal to n over 2, and then I have T1 plus t1 plus n minus 1 times d. But this is actually just tn, right? t1 plus n minus 1 times d is just tn. So I can write this as n over 2 times t1 plus tn. And that is how we derive the equations that we're going to be using. We're going to be using this equation, and we're going to be using this equation for solving for sums of the series.